So we are up to 522, properties of logarithms. It's overwhelming at first, but if you hang in there, give me a chance to explain it. I hope that it'll make it simple. So, all this is saying is if you have the log of two things being multiplied, I call this the log splitter. Now think about that. You take your maul, you smack a piece of big old log, you cut it into two. This is a rule that cuts the log, one log, into two logs. So if we have multiplication there, it splits into the log, the sum of the separate logs. So, but there's the reverse rule. So if we go this way, I call it the log splitter. But if we go this way, I call it marriage from Princess Bride, because the two shall become one. So we split it by turning multiplication into two addition problems. But an addition problem of two logs turns into one log, and these pieces are multiplied. So let me show you an example. So over here, I already used my calculator. I typed in log of 6, and I got 0.778. I split it into two logs. So the log of 2 plus the log of 3. Log of 2 is 0.301. Log of 3 is 0.477. Do the math. It's perfect. But I could also go this way, and this is the marriage. The 2 shall become 1. So it's a log of 6. You just multiply the 2 times the 3. Here's another one. We got the log of two things being divided. What is that? So I take the maul going this way, and it splits into the log of the top one minus the log of the bottom one. That is the splitter. Marriage, if I see subtraction, that means I turn it into one log, the first piece there divided by the second piece there. To prove that it works, I took my calculator, I took the log of 3.5 and I got that. I split that into two logs, and so the log of 7 is 0.845, log of 2 is 0.301. Subtract this, I get that exact thing. But I could also go this way. Marriage, the 2 shall become 1. Subtraction is the same thing as division. Divide 7 by 2, and it works that way as well. The last one isn't really a log splitter or marriage, it's just moving something around. So this rule says, if you have an exponent in the answer spot, that's what I've been calling it, you can throw it in the front of the log, kind of like that. When would you ever need to do that? Well, you're going to have some problems that are going to force you to use this law, so be on the lookout for it. Always be on the lookout for law 3 first. That doesn't make sense to you right now, but I'm going to come back to that theme in a minute. So let's mess around with it. So I typed in my calculator log of 9, and I got 0.954. I moved that in the front, just following the rule, and I typed in log of 3, and I got 0.477 times 2. Guess what that is? That. But I can go this way, but I can also go that way. So if I have a coefficient in the front, I can just stick it right up there as an exponent of that thing in the answer position. That's a warm-up. Now we're going to actually put these rules, laws, into action. So give me a second, and I'll put some up for you. All right, so let's put a few of these laws into action. So the instructions for us are rewrite as a single log. Okay, well let's break this up into bite-sized pieces. Black marker's not working too good. But what does plus mean? Well, the 2 shall become 1 if I have two logs separated by addition. That means I write them as a product with log base 3, 72. Then I've got minus log 3, 4. Well, now these two shall become 1 using this rule. I I can write it as a single log. If I take the first, my base is 3, take the first one in the top, second one goes in the bottom, and you just do your best job reducing that. So 4 goes into 4 goes into 72, how many times? 18 times. And there, we have written it as a single log. So it's just an exercise using your logs. So let me continue here. Let me take a peek at something. Make sure we're doing this. We're not, okay, yep. All right. So follow the rules. Write it as a single log. Well, I've got this plus this. Let's focus on those two first. Addition means multiply and turn them into one log. So this is the natural log though, but don't worry, they still apply to natural logs. I multiply those together, and then I got the natural log of 3. Well, I still don't have a single log, so addition means multiply those two things and turn it into one log by multiplying the 3 times the 9. You're done. So let's go on to this one. I'm going to pause on this, and I'm going to go over here and take a look at this. And anyways, natural log is something you got to be on the lookout for, because there's an invisible e here, and e to some power 1 equals e. So whenever you see the natural log of e, you just replace it with 1. Now, I don't think that's really what they want us to do right now, but I'm throwing this in so you're looking for it. This one, there's an invisible 10 there. 10 to the first power is 10. There's an invisible 10 there. 10 to the second power is 100. There's an invisible 10 there. 10 to the third power. So when you see this, you can replace it with 3. When you see this, replace it with 2. When you see this, replace it with 1. When you see natural log of e, most of the time you replace it with 1. So I just want you to be on the lookout for that. But what they want us to do is just follow our rules. Forget that that equals 1. Just follow the rule. The 2 shall become 1. Subtraction means the first guy goes in the top, second guy goes in the bottom. And that's plus the natural log of 2. Addition means I multiply these two things together, so I get the natural log of 2e all over 5. And that's it for writing as a single log. Now sometimes they'll give you something crazy like this, where you're like, well, it already is a single log. Well, they just want you to use law 3. So you go, oh, that's 2 cubed log of 8. So sometimes the instructions are weird, but they just want you to practice your logs. So if law 3 is sitting there, then apply that law. Okay, one more thing to show you for this lesson. So you will see that this lesson, this portion's just a quick review of the letter I, the imaginary number I equals the square root of -1. So if I squared that, I would get -1. Just like the square root of 2 times the square root of 2 is 2, the square root of -1 times the square root of -1 is -1. Now be careful, a lot of students want to multiply those together and get a positive 1, and that's not what happens. Square root of -1 times the square root of -1 is -1. So 3i times 2i is 6i squared, which is 6 times -1, which is -6. A little warm up. This one is a FOIL problem. 2 times 2 is 4. 2i, -2i, -i, positive I is -i squared. These cancel. I squared is a -1, so if I just put a -1 in there, these two negatives make a positive, so 4 plus 1 is 5. Now we're going to really put it into practice. This is the language you guys are used to. If f of x equals this, find f of I. In other words, wherever x shows up, throw an I in there. So I get I squared plus 3i minus 1. Well, I squared is a -1. -1 minus 1 is -2 plus 3i. Now things are going to get a little bit more complex. We got to plug all this in for this and this. So I get negative 1 plus I squared, negative 1 plus I plus 3, going to have to dip down here, times negative 1 plus I minus 1. So, got to FOIL this out. Negative 1 is positive 1. Negative 1I and negative 1I is negative 2I. I times I is I squared, which is negative 1. I'm going to distribute, minus 3 plus 3I, and that little negative 1 is just coming along for the ride. Now we're looking for like terms. 1 minus 1, these two things cancel. So I get negative 3 minus 1 is negative 4. Negative 2I plus 3I is 1I, or just I. And there's my answer to that. Not too bad. FOIL and using your functions. One more thing. Last problem. We've seen a problem like this before, but I think it's just wonky enough where we should look at it one more time, just build that confidence. So step one, you find out what x cannot equal. You look at the denominator and you say, hey, that stuff cannot equal 0. So we've got to figure out where it does equal 0. So we say x equals negative 3/2 is what x cannot be. And I know that's negative 1.5. And so that's a hole in the graph. Now, we're going to find out exactly what value for x is a threshold value. I don't think I used that word the first time I taught it, but we're just going to actually solve now by multiplying by 2x plus 3. It's going to cancel on that side. So I get x plus 9, but I got to multiply this through here as well. So I get 4x plus 6. Less than or equal to 4x plus 6. I'm going to subtract x, subtract 6, subtract 6. By the way, if you multiply an inequality by a negative, flip the inequality. I hope you remember that. So I get 3, and then I get 3x is greater than that. So divide by 3, I get x greater than or equal to 1. Now, this is a threshold number. So at 1, right here, I know either this side's going to work, x is greater than or equal to 1, so we're thinking this side is probably going to work, but we have to test all three areas. This area, this area, this area. So let's just take the number. I'm going to rewrite this, 2x plus 3, get rid of all this stuff, get a red marker so it pops out. Let's go negative 2 and see if this actually is true. So I would get negative 2 plus 9 is 7. Negative 2 times 2 is negative 4. Plus 3 is negative 1. Is less than or equal to 2. And that's true. So I definitely have a space here, negative infinity, all the way up to negative 1.5, but it doesn't include it because that's a hole. That's why I use parentheses. Now let's test this space right here. Easiest thing to pop in there is a 0. So that'd be 9 over 3, which is 3. And is 3 less than or equal to 2? No. So now we're going to test this space over here, which is very likely. Let's plug in a 2. 2 plus 9 is 11. 2 times 2 is 4. 4 plus 7, or 4 plus 3 is 7. Is that less than or equal to 2? Yes. So my other space, together with 1 actually works because of the less than or equals. Let's bracket 1 all the way up to infinity. So all of these numbers and all of these numbers. That's what you're trying to communicate there. And that does it. So good luck on your homework.